All right, everybody. Today we're going to be doing lesson 7.7, both sides of our worksheet. We're going to do both factoring by polynomials by difference of squares and factoring polynomials by grouping. So let's go ahead and get started. This is a quick review of the FOIL method. Technically, it does not matter what order you go in as long as you multiply everything right here by everything right here. In fact, you could almost break this down and say that this is x times x minus 4 plus 4 times x minus 4. As long as you have this all figured out and you have it all multiplied together, it honestly does not matter the order. We do want it in standard form at the end though. So FOIL method is nice because it goes in order for the most part. So we've got x times x squared, that's our FOIL first. So then we've got outer, so we've got x and negative 4. So as you can see, I just multiplied x by both things first. Then we've got inner. Now we're multiplying the 4 plus 4x and the 4 minus 16. As you guys can see, following FOIL method, I basically multiplied the second parenthesis by my x first, and then the second parenthesis by my 4. As long as everything's get multiplied together, it's all good. Now you'll notice that the middle cancels out. We're left with x squared minus 16. Today, we're going to learn how to go backwards from this point all the way back to the original how it looked. So let's go ahead and do that. So this is what we're going to be looking at. We are going to be creating these problems. Now, 4x squared minus 16 is not the same as 4x squared minus 16x. We're going to talk about this a little bit more later, so let's keep moving. All right, so here's how it works. We have a squared. Well, a squared is just a times a. What times itself gives me 4? Well, 2 times 2. However, since this is negative, I've got to have one of these 2's be positive and one of these 2's be negative. So this is what this looks like. I have a plus 2 and a minus 2. Now it does not matter the order you go in with these pluses and minuses. For example, this one in minus 8, in plus 8. I do not care if your minus comes first or your plus comes first, and it does not matter. Alrighty, we got to keep looking. Now there is a special thing I want you to notice. This is a subtraction sign right here, whereas this is a plus. So pay attention to the fact that negative 10 times positive 10 gives me negative 100. However, there is no combination of things that will cancel out and still give me positive 25. So for example, I've got 5 times 5 and negative 5 times negative 5. That's great, but the problem is when you do k plus 5 times k plus 5, you end up with k squared, following our FOIL method, plus 5k, following our FOIL method, plus 5k again, and plus 25. These two that are supposed to cancel out to give us this shortened version up top, they don't cancel out. So this is actually called prime. So for this problem right here, this is called prime. Basically, if it's set up like this, with a plus sign in the middle between them, it is prime. You cannot factor that. Over here, it's a subtraction. The whole goal is for it to cancel out. C plus 10 and C minus 10. When I distribute those out and FOIL those out, I get C squared plus 10C minus 10C minus 100. This middle cancels out, and I'm left with what I started with. That's the goal. You do not have, guys, this is your answer. You're good right here. I am just explaining why, and why this is prime and why it has no answer. Okay, now, you need to go follow the order of whatever it's in. So for example, 81 minus x squared. Okay, well, 9 times 9 gives me 81. I need to put a 9 first, minus x. And a 9 here, plus x. Technically, you could say negative x plus 9 and x plus 9, but I have a very strong feeling a lot of you would forget this negative here. So I would just suggest sticking with this. So same idea over here. I'm going to put my constant first. That's A-okay. I've got 1 minus 7y and 1 plus 7y. Boom. Alrighty, so here we go. We're going to look at 13. Now we've got x squared, y squared. Okay, so I've got x times x gives me x squared, and y times y gives me y squared. Guess what? 1 times 1 gives me 1. So I can do plus 1 and xy minus 1. On 14, we're looking at the fact that this is now into the fourth. Well, when we multiply our bases, we add our exponents. This has got to be 9n squared plus 5 and 9n squared minus 5. In order, they have to be squared so that they add up to 4 at the end. Awesome. All right, so we wanted to look at some of the homework problems real quick because these require simplification first. If you see problems like this, you can check and see if you can divide both terms by the same number. For example, I can divide this term and this term by 3. That leaves me with p squared minus 25. Now the 3 is left outside. That's how I indicate it didn't go away. You can't just divide it out and it disappears forever. We have to represent that 3. But now I can solve it just like we did before. I've got 3, p minus 5, p plus 5. And this is my final answer. Same idea with this one. You can divide both by 7. Divide both by 7. So now I've got 7 outside. N squared minus 1. So now I can put 7. N minus 1. N plus 1. I've run out of room for 17, so give me a second. Alrighty, so 17. We can divide both terms by 3. So now I'm left with 3 outside. X squared minus y squared. Now this one is going to be 3x minus y, x plus y. And that is your final answer. And that is difference of squares. Now we're going to flip over our paper and we're going to go to grouping. Wait a second, let me make sure there's not one on here I want to look at. There was one on here I want to look at, 23 and 21. So guys, if the thing that can be pulled out is the variable, that's perfectly fine. I can pull out k squared, and then I've got 3k squared minus 48. Oh, but I can pull out more than just k squared. I can pull out 3k squared. So I'm left with k squared minus, remember guys, if you don't have your calculator at home, you can real quick do it. 3 into 48, I've got 1. 16. Alrighty, so I've got 3k squared, k plus 4, k minus 4. Alright, let's keep going. Factor by grouping. Now, factoring by grouping, we're going to basically split this into 2 different things. So I'm going to split this section and this section. Now, factor out the greatest common factor for each binomial. That's 2. And that's what we have right here. We have 2 here and 2 here. So, on this first one, I can factor out, let's see, I can factor out x squared. Why? Because x to the third is actually x times x times x. X squared is actually x times x. So I can remove two x's from each of these. There is no negative exponents. You do not take from what isn't there. So we're going to have x plus 7. The 7 remains. And I want to make sure I write this. Hold on a second. I've got x, and what's left inside is x plus 7. So then what's left out the other one? What can we divide from the other one? We've got plus 2. What's left is x plus 7. Actually, they are identical, and they have to be identical. So we are going to now bring down x plus 2, put it in a parentheses, and one of the x plus 7s. Remember earlier I said that FOILing is just basically multiplying x times everything in the second one and 2 times everything in the second one. That's all we've done. We've just gone backwards with it. We use FOIL to check our answer, so I'm going to multiply x times x squared, x times 7, 7x. I'm multiplying 2 times x, 2x, 2 times 7, 14. And we now have, whoops, I forgot to put my x squared right here. So sorry about that, guys. My bad. And that would make this the third and this squared. So let me, right, there we go. Now you can see them a little better. Awesome. Sorry about that, guys. Please pay attention to your exponents. This kind of thing can happen real quick. But you can double check yourself because I know that this has to match the top. So I was able to tell, oh, it's supposed to be x squared right here because this has got to equal x to the third at the end. Awesome. Let's look at, okay, there we go. Number 1, we've got to break them into 2 different groups. So I've got a group right here and a group right here. You notice I'm including the sign in front of the 2. That is because the sign in front of something is what goes with that term. So I can pull a 3x squared out of the first group. And what's left inside is x plus 5. I can pull a -2 out of the second group, and what's left is x plus 5. These have to be the exact same. This has got to be x plus 5 and x plus 5. You could not have x plus 5 and x minus 5. That's why it's really important that I pulled out the negative in that. So I've got 3x squared minus 2. 3x squared minus 2. And I've got x plus 5. Alrighty, let's go into, alrighty. So again, okay, one of the important things you need to pay attention to is it in standard form? Standard form goes, we have to make sure we're going in A, B, C order, alphabetical order, and we are going from greatest to least with our exponents. So, for example, I can check up here. I've only got one exponent. Cool. So I'm good with the exponents. I'm good with the variables. I've only got one type of variable. My exponents, 3, 2, 1, none. Perfect. Awesome. So we're going to go on. So I've got one group right here. And again, I'm including my sign, that negative in front of that 5x. So I'm going to pull out x squared. What's left inside is x plus 2. Let's go ahead and look at over here. Okay, now I'm going to show you what happens if you don't pull out the negative. Let's say I just pulled out plus 5. Inside, I would have negative x minus 2. Does negative x equal positive x? No. Does positive 2 equal negative 2? No. So, that is why it is extremely important that when you are doing this, you make sure you pull out the negative if needed. In this case, it is absolutely needed so that we can have x plus 2 and x plus 2. So now we pull down x squared minus 5, and we pull down x plus 2. Excellent. And just a reminder, this is your answer. You are good. You don't have to FOIL it out. FOILing it out helps you to check it if you're unsure. But if you're in a rush, this is your answer. You are done. All right, let's go on to, here we go, different variables. So I'm going to break it up again. I've got the first two. It is in standard form. I've got y squared minus y. Then it combines to yz. And the last ends with z. Y comes first. Perfect. Alrighty. I am including this plus sign. Always include the sign. Now let's see. What can I pull out? I can pull out y, and I can also pull out 3. Now I cannot pull out y squared because there is not a square on the second y here. You cannot pull out what is not there. Also, please remember, we don't want negative exponents. So technically, yeah, you can divide by y squared, but that would give us a negative exponent and a fraction, and we're not doing that. So we've got left 2y minus 1. Remember, anything divided by itself is 1. It does not disappear. It does not become 0. It is 1. So, pulling out from the second one, I can pull out positive z. I am left with inside 2y minus 1 again. Again, my blue matches my blue. My inside matches my inside. We're good to go. So I've got 3y plus z. And I've got 2y minus 1. Excellent. Let's do, alrighty. And let's do one more real quick. We'll do 6 real quick. Alright, so I am going to break it up. Again, the negative goes with the 7. It does not go with the 3x. It's whatever's in front goes with that term. So I'm going to pull out x squared. This time there is an x squared in both of them. So I can pull out x squared. And I'm left with, let's do this color. I am left with y. Ooh, that does not show up at all. Hold on. Y plus 3. Awesome. So, looking at my second one, I can pull out, I need to pull out negative 7 and only one y. I am left inside with y plus 3. So, I've got x squared minus 7y. And last but not least, I have y plus 3. That's it. And I hope you guys, if you have any questions, reach out. I hope this video helped you guys.